All right, let's look at one single interface and how it can be used by or implemented by multiple different concrete classes. To do this, I've developed the Increment Interface. All it has is next, skip, and reset. So to implement the Increment Interface, your class must be able to take some next step from wherever it is, reset to some original state, and possibly skip ahead some number of steps as well. Well, no, it definitely must be able to skip ahead. All three of these will be required by anything that says it implements the increment interface. That's a little hard to say. So I'll first start with my count class. All this class is going to do is to maintain a count, an integer count. So, for instance, when we have a new count object created, it should take an integer that is the starting value for it, and it should set this dot count equal to that count that was passed in. I believe that's how I've set it up here in my increment app. All this is doing is a simple text interface that will allow us to add more increment objects and see how they function. And because they all follow the same increment interface, I'm going to be able to store them all in one array, whether they're a count, a clock, or a turtle, as we'll see in our examples here. So my code doesn't compile right now because I said that count implements the increment interface, but then I didn't actually implement the different methods that the increment interface requires. I should be able to use IntelliJ to say Control I, and it will suggest to me all of the methods that need implemented. So here we have them: next, reset, and skip. They're all void, so my code should compile right now, just like this. But let's make them actually do something. For instance, next should increase my count by 1. So it will just do count plus plus, and then it's done with its job. Reset should reset my count to whatever its original value was. So to do that, I'm going to have to actually track what the original value was and set that in my constructor here. Then all I have to do is say that the count goes back to my original, and I should be all set there. For skip, I could add that amount to my count. I also could do something that's going to work for any of my classes here, which is I could do a loop from I equals 0 to the amount and do I plus plus, and then inside of there, I just call next. So whatever next is supposed to do, I'll do it over and over. This is a little bit of overkill for my count where I could have just added amount, but we'll see that this is a really good basis for all my other ones that have a little more complicated of next steps for them. All right, so I've implemented the increment interface. I'm getting good at saying that now. With the count, so I should be able to run my increment app, and it should ask me what I want to do in just a moment. It's set up to accept the letter N for next, R for reset, or a number that tells it an amount to skip. So if I say next, so my counts are missing something. They don't actually know how to print themselves out. So I will have to add one more thing to make them actually useful, and that's a toString. So for this, that should be easy. And now I should have a useful toString. Let's try again. Now when I'm asking to do next, I should get 1 for the first one and 101 for the second, because the first one started at 0 and the second one started at 100. And I can keep asking for next, and both of them will get incremented using their next methods there. I can reset them, and now they're back to 0 and 100 respectively. And I can continue doing next from there. I can even skip ahead by a certain amount. If I skip ahead by 4, then 1 goes to 5, and 101 goes to 105. If I skip by 100, then you see each of them increased by 100. Not too bad, but also not the most interesting way to do this incrementing, this step sort of thing. Something that might be a little more interesting would be a clock. I've cheated and started the clock class off a little bit with a toString that will nicely format it as a clock and a constructor that doesn't take anything for the moment. So I'm going to say that clock implements increment, and then I'm going to do Control-I to get those methods that I need from the increment interface. So when my clock does next, it's a little different than my count, because yes, my minutes should increase, but if my minutes raised over 60, actually greater than 59, then I should set my minutes back to 0 and increase my hours. And if my hours increased past 12, then they should reset to 1. And so that should cause my clock to step by minutes until it passes an hour's amount and go forward to the next hour and the next. Reset, we'll just have it reset hours to 12 and minutes to 1. And I should start them at 12 and not 1, 0. All right, and skip. Now I can do that thing that I talked about from here, where rather than having to recreate all of this logic of did the minutes get too large, etc., we can just do a for loop and call next, and next will track. If I pass an hour, that's okay. It will call the next. So because this implements the increment interface, I'm able to just add it to the same list. I'll make the the same array. I'm going to make it a little larger, and then I'm going to assign at index 2 a new clock. And clocks have a next, they have a reset, they have a skip, just like counts did. And so it should work just as smoothly as the count did. Let's see. When I say next, I have 1 for one count, 101 for another, and 1201 for the clock. And the clock minutes increase perfectly reasonably there. They reset back to 12 o'clock without any problems. And if I tell it to skip by, say, 62, we see that it passes from 1201 to 103. If I tell it to skip by 120, then it should be 303 now. And so it functions as a clock. And if I were to get this to skip all the way to 12 again, it would flip forward to 1 after that, 1 o'clock after that. So now we have a functioning clock. It's not that different from the count, though. They both are basically keeping account of something. It's just the clock is doing a little extra tracking and a little extra formatting. Let's do something that's very different. We'll create the turtle class that will also implement the increment interface. Still hard to say. Implements increment. And we will make sure that it actually gets the right methods to do so. Okay, so what its next is going to do is to add space so that the turtle sort of crawls across our screen. So what we want to do is for each of the indexes in my string array called cur, I want to increase it by one string or by one space. So I equals 0, I less than cur dot length, I plus plus, cur I plus equals space. Let's make sure we get this right. So for each spot, it will add one space. Reset should be pretty easy because I can just reset it to that original turtle who hasn't got any spaces before it. And skip, I can steal that same for loop and just call next over and over rather than having to redo the logic again. And now, my increment app can have a new item in there. It can have a turtle. So at index 3, I'm going to make a new turtle. So this is a pretty different kind of increment item. But again, it follows the interface. The interface doesn't specify what next means and how next is going to work. It just says that next will call the next of, or we'll get the next of whatever we're supposed to have there. I could create this increment thing to give me the next power of 2. I could create it to give me the next name on a roster, whatever I wanted to do. So we can see the turtle is there. It's stepping slowly across the screen. You can barely see it. And if I skip by 12, oh, it's not moving. Wonder what I did wrong there. So for each of those current, I put the space. After I really made sure that I wanted to get it right, I put the space on the wrong side. So let's put the space on the right side and try again. So I'll see the turtle stepping a little, stepping a little, stepping a little. Much clearer to see when it's actually doing it. And it steps forward by 10, and it steps forward by 3, and so on. And I can reset it to where it comes right back to the start. And you can see that all the counters and the clock were also incrementing. We tell them all to do next or to skip or to reset, and they all have their own model for doing this. So you can imagine how an interface could be used in a program to say, put some, or to give some grouping between all of the characters in a video game. They may all run or attack or do whatever they do differently, but you can define an interface, a common set of behavior that they all will follow, and then that allows you to store them together in a single array, to have interfaces or to have user interfaces that let you interact with each of them according to their individual functionality. And they can all be pretty different from each other and still follow this same basic interface. And we'll see plenty more of this through your projects and all throughout the class too.